Hi guys, today we will learn a curious concept that was how to store charge. Till now we discussed a lot about charge. Now this is the time to make real use of charge. For that we need to store charge. So that is our task, how to store charge. So you might see these kind of electrical components in electrical circuits. So they will come with different sizes and different shapes also, and they known as capacitors. So these all are the and electrical components. They will come with the different sizes and they will come with the different shapes also. So those known as capacitors. So the capacitors can store charge. So today we will go through how these capacitors store electric charge. And as per I said, so these will come with the different sizes and different shapes. And these are the DC capacitors. Means we can use them as for the direct current. And there are the another type. So here you can see these DC capacitors comes with a wide range from small to big. So they are having very wide range, and we need to discuss what could be the cause for they will come with different sizes and different shapes. And if you can take, these are the well known familiar for us. So these are the AC capacitors, means we can use this for alternating current, and the previous ones we are using for the direct current. Now these also will comes with the different sizes and different shapes. Now if you can see the uses of the capacitor, so in ordinary language, so they also called as condenser. So the condenser or capacitor is the a necessary component for all this electrical motor which used to rotate. Now this fan should need this capacitor to function. Not only that, if you can see, this cooler also is the needed component. So these are the two familiar example for us. So where we can use the capacitors. Let's define capacitance of capacitor. So capacitors are devices that store electric charge. So let's see certain examples where you can use mostly these capacitors. The capacitors are widely used in almost all electrical components, all electrical circuits, and they are the energy storage devices. So they can store energy. So that energy or charge. So they can store the charge mainly almost all, just like radio receivers, filters, or eliminate sparking in automobile ignition systems, or a wide range sources they can be used to storage energy, electrical energy. Now let's understand in detail how to make up a capacitor. So what are the necessary things we need to make up or to construct a capacitor? Now capacitor consists of two conductors. To construct a capacitor, we should need two conductors. And these conductors are called as plate. Two plates. Now, when the conductors is charged, the plates carry charges. It means suppose if you have two plates, so to these two plates you need to be charged to the charge. So here we need to apply source. Here the source is a battery. So with the help of the battery, so what happens? So this plates gets charged. Now the magnitude of the charge on these two plates is same, so they can get the equal amount of the magnitude, but the sum of the charge on the total capacitor will be equal to 0. Why? Because one plate accumulates positive charge and another plates accumulate negative charge. Now to construct a capacitor we need two conducting plates, and that conducting plate should be charged. So just like shown at here. Now after that, a potential difference exists between the plates due to the charge. So if these two are the two conducting plates as shown at here, so this is the positive charge and this is the negatively charged conducting plates. Obviously electric field exists between them, and also we already learned between them potential difference will be exist. Suppose if we can connect a voltmeter at here, so it will shows the potential difference what is exist between them. Now this setup will make use for the capacitor. So let's see further. According to capacitance definition, so this is a very important definition. The capacitance, C, we are using a letter. The capacitance of a capacitor is defined as the ratio of the magnitude of the charge on either conductor of to the potential difference between the conductors. Now if we can write that as simple formula, capacitance of a capacitor C, which equal to, it's a ratio, means nothing but we have to divide. What we need to divide? We need to divide the charge on either plate. I can take charge as Q on either plate upon potential difference. So here I can use potential difference delta V, or simply we can use it's upon a simple formula Q by V. So here V is the potential difference between the two plates and Q is the amount of charge. So this ratio we define as capacitance. So a simple definition, the capacitance of a capacitor is defined as charge to potential difference ratio, the ratio of charge to the potential difference. If you can divide that two quantities, the scalar over scalar, we can get a scalar. So capacitor charge is a scalar quantity and potential difference is also a scalar quantity. So that ratio gives a new quantity that we call as capacitance. So capacitance C is equal to Q upon V, and the SI unit of capacitance is the farad. So we can use the SI unit for a capacitance as farad. Since the farad is a large unit, so we can represent that as capital F. 1 farad is very large units for capacitance, just like a charge. 1 coulomb is a very bigger unit for the charge. So we used to represent charge as millicoulomb or microcoulomb. Likely at here also 1 farad is a very large unit, so we will represent capacitance in terms of smaller units, either microfarads, millifarads or picofarads or nanofarads. And capacitance will always be a positive quantity. Yeah, because the potential differences comes always in terms of the positive we can take, and charges also take positive. So capacitance will always be a positive quantity. Now the capacitance of a given capacitor is a constant. So for a given capacitor, the capacitance value is always constant. That's the reason why the capacitors are comes under different sizes. If you want to use one capacitor, only one particular value, its capacitance do not will change. So that's the main reason the capacitance of a capacitor is a constant. So if you want to store a large amount of charge, obviously we need to construct such a big capacitor. Finally, the capacitance is a measure of the capacitor's ability to store charge. So this is my starting word which I chosen. Capacitance is a measure of capacitor, the ability to store charge. So capacitors, they will store charge. If you want to store more charge, obviously you need to increase the capacitance of capacitor more. Now we can define the same definition in different manner. That is, the capacitance of a capacitor is the amount of the charge the capacitor can store per unit potential difference. So you can write the formula C is equal to Q upon delta V. So this definition you understand like this. So the capacitance of a capacitor. So this is the definition you want to say. So the amount of charge stored per unit potential difference. Suppose if you take, if delta V equal to 1 volt, that is the unit. So for the potential difference of the for for the potential difference of 1 volt, how much charge can be stored is defined as the capacitance of a capacitor. Repeating again, if the potential difference is equal to 1 volt between the two conducting plates, so in that case, how much charge can able to store by the capacitor is defined its capacitance. So that is the definition of capacitance of a capacitor. Let's construct a capacitor and let's understand the mechanism of how a capacitor stores charge with the help of a PHET stimulation. To construct a very simple capacitor, so let's try to construct a parallel plate capacitor. So what essentially capacitor contains? Capacitor should contains two conducting plates. Yeah, here two conducting plates. Here you can take, this is the plate 1 and the plate 2. They are separated by a distance d. So in between the medium air is present and there is a certain gap. And now these two plates should be charged. So here the battery is the source, it is having the potential difference. So obviously this potential difference if we apply to one is a positive plate, one is another plate, sorry, negative plate. So the plates gets charged. Now here we need to understand in detail how a charge will be accumulated by these plates. So for a simple capacitor construction, so it contains two conducting plates and that conducting plate should apply by a potential difference, because without the potential difference charge cannot flow. To flow charge, potential difference must and should. Now initially if the capacitor is uncharged, now we do not connect the battery to these two plates. Now the two plates are uncharged just like ordinary plates, neutral plates. Now when you connect this battery to these two plates, now these two gets charged. How did they accumulate charge? Let's see here the virtual stimulation. So here I am having a setup. So this setup contains, so these two are the two conducting plates, and these two conducting plates are connected via these wires. So these are, and this is a wire, and here the battery, it is my source, potential difference source. Now if you can see closely, so the connections are made. So the battery is having at 0 volt potential. Now, so here I am having option, I can just disconnect the conducting wires. First, let's measure the potential difference of the battery. Now we can take the battery contains two terminals, one is the positive and one is the negative terminals. And if you can apply positive terminal to the positive and negative terminal to the negative of the voltmeter, now here the potential difference at the 0 volt, now the voltmeter is also showing 0 volt. Now if you can switch that to maximum 1.5 volt, now the voltmeter is also showing 1.5 volt. So that is the way to measure the potential difference. It's a difference. Suppose if you can switch that to the down, automatically the voltmeter will be shows negative, because the terminals I did not switch now. So to measure voltmeter properly, we always use these terminals properly. So where the negative terminal is there, so there we have to use the negative probe, and where the positive terminal is there, there you have to use the positive terminal. Now here we can see, now the voltmeter is showing now at here again the positive voltage. Now if I take out this voltmeter for time, and I will give to the 0 volt, let me connect. So I connected these two conducting plates to the source. Now if I apply a potential difference, now if I apply the potential difference, yeah, this is the somewhat potential difference. So let me know what is the potential difference right now. So that is showing, now it is showing negative here, that is the go there, and you go at here. Yeah, now it is showing roughly it's 0.9 volt. So let me fix that to as a 1 volt. Yeah, let me apply. So at here I applied 1 volt potential difference. So there is a 1 volt potential difference. Now let us think here how this plate gets positive charge. Now since it gets positive charge and it's a conducting plates, it's a metal conductor. When a conductor becomes positive, if it loses electrons, it means the electrons are started to move from the wire, from this conducting plate, because of this potential difference, and these electrons are reach to another plate. So this is the direction of the flow of the electrons. And why did the electrons move? What could be the cause? So because we applied the potential difference at here. So first the potential difference what we applied at this potential difference will create electric field, and that electric field first interact the electrons within the wire. Electrons within the wire. Now the electrons are having the tendency, they will move from higher potential higher potential to lower potential. Since this is created an electric field, this electric field, the battery created an electric field. That electric field is first affected on this wire. Now the wire contains electrons. Yeah, it's a conducting wire. So now the electrons starts to move. Where they will move? They will move from the higher potential to lower potential. So the electrons right now adhere within the wire. So the electrons which are there in the wire, they start to move. So they will move. So they will move via the battery. So they will start to move. So here automatically you created a potential difference. So this wire is connected to this conducting plate. Now the electrons within the conducting plate also they starts to move. They will take this path and they will reach to the lower potential. So but the lower potential is connected to this another conducting plate. Now all the electrons will be accumulated to the negative plate. So that's why one becomes positive charged plate, another becomes negative charged plate. Now once when these electrons all reached and they will come to an equilibrium position. So in the equilibrium positions, electrons won't flow. So it means they are not flowing. It means between the two conducting plates, there will be no potential difference. Electrons will flow till the potential difference exists. Suppose if I measure the potential difference at here, not on the cell, for the cell it is showing, let me clear this writing. Now that is the potential difference what is showing the voltmeter 1.0 volt on the from the battery. Suppose if I measure the same potential difference from the conducting plates. Now the conducting plates also showing the same potential difference. It means what is the potential difference exists in the battery, same potential difference this conducting plates also reached. Now these conducting plates are having the same potential difference. Now enter the circuit is having the same potential. Now if it is the same potential, electrons won't flow. Electrons will flow only from higher potential to lower potential till the potential difference exists. Now this became a positive conducting plate and one more another becomes negative conducting plate. Suppose if I disconnected. Now if I disconnected from the source, so still the electric field is exist between them. Yeah, because this conducting plates is one is the positive charged plate and one is the negative charged plate till the charge is exist. Now if you use something to discharge or if you connect any other things to get discharge, till that the charge will remains on this plate. So this is how they can store charge. Now here we can mention the capacitance formula at here. The capacitance of a capacitor C is equal to Q upon V. So here the Q is the magnitude of charge on either plate and V is the potential difference. So the potential difference between the two plates. So here the potential difference between the two plates is equal to 1 volt. And our task is to find out how to find the charge on that plate. So that we will do little mathematics. So that is very easy to understand that mathematics. Now finally I can write capacitance of a capacitor C is equal to Q upon V. So here the Q equal to the charge on the plate, and the V is the potential difference. So that potential difference is the applied potential difference from the source what we applied. Now let me use an external source. Suppose if I'm having a setup at here. Now the same setup. First let me charge the plates. So here the capacitors are charged. They charged. Right now I am disconnecting the capacitor. Now this capacitor having energy. It's a stored charge. Charge is stored. So it's having capacitance. Suppose if I connected to that a source. So here the source is my bulb. Now if I connect this to this bulb, what happens? What is the potential difference is at here. So because of the potential difference, the same charge will flow from this circuit if I connect. Now let me connect and see. Suppose if you connect at here, if you can notice the brightness of the glowing of the bulb. Now here you can see the bulb brightness is decreased, and the parallelly the amount of the charge is also decreased. Let me charge one more time. Now that is the capacitor is charged. Now it is disconnected. Now the charge is stored, and these two plates are having the potential difference, and that if you are connecting to a bulb. Now what happens at here? Because of the existing of the potential difference between the two plates, now the charge will flow. Now the charge will flow. If you can closely observe, the electrons will flow from the negative plate to the positive plate. That is the direction of current. So because of the flow of the electrons, that contributes current. So now the bulb is glowing. Now here you can see the amount of the charge is decreasing. Now the same, let me try one more time. It's more fun. So now the capacitor is fully charged. Now it is disconnected. Now let me connect to a bulb. Now you can closely observe the amount of the charge and the intensity of the light. Now the light intensity is all of a sudden bright, and then after the light intensity starts to diminish. Why? Because of the amount of the charge flowing initially is large. So that you can understand if we connect a voltmeter at here. So because that is not the constant voltage. If the constant voltage, so the bulb is always glow brightly, means constantly, just like at our houses. But this is just like flashlight. Now here the capacitance voltage you can observe they are having 1.5 volt. Now if I connect at here, you can put close look on the voltmeter. So the voltmeter, the voltage value is dropping while the intensity is decreasing. Now why the voltage is dropping? Because charge is used by the bulb. So that's the reason. Potential difference. Now there is no potential at here. Now there is no light, or there is no intensity on the bulb. So here the bulb is directly not connected to the source. Here we connected to that via a capacitor. Now that is the advantage of the capacitor, how it can use or how it can store the charges. So let's summarize what we learned till now. So the plate, the wire and the terminals are at the same potential. At this point, there is no electric field present in the wire, and the movement of the electron stops. So if you can take this continuity at here, so this is the continuation. First let us take two conducting plates and let's connect it to that battery. What was the total mechanism? Just I would like to just summarize. For that, first we need to take two conducting plates, and that conducting plates are initially uncharged. They are initially uncharged. Now we need to connect that to a battery. Now what happens? The battery establishes electric field first in the connecting wires, because the connecting wire is only the interconnection between the plate to the battery. Now after that, the field applies a force. The electric field caused by this battery, they apply a force on electrons in the wire just outside the plate. Now that force causes electrons to move onto the negative plate, and the electrons will move until the both plates should reach the equilibrium position. Means the potential remains constant throughout the circuit, and after that the plate, the wire and the terminals all are at same potential. If they are at the same potential, there is no movement of the electrons, because no potential difference. If there is no potential difference, electrons, they cannot move. Now one plate is negatively charged and another plate is positively charged, and its final configuration, the potential difference across the capacitor plate is same as between the terminals of the battery. Now what is the potential difference we applied? So if it is a capacitor plates and you applied a potential difference via battery, so let's take as this 10 volt. After certain time, means very fraction of seconds, so one plate gets positive charge, another plate gets negative charge, and this is also will reaches same potential difference. If you can connect a voltmeter, so that's also reaches to 10 volt. Now here if you can disconnected this, now the capacitors having the potential difference of the 10 volt. Now that we will use, and that's how a capacitor stores charge. Now let's understand one more question at here. Why the capacitors are comes with different sizes? So as per we learned, so capacitance is a ability to store charge. The capacitance of a capacitor is ability to store charge. C is equal to Q upon V. Suppose you want to store more charge, if you can apply potential difference, you want to store more charge, so that capacitor should able to store its capacitance of a capacitor also should increases. Okay. Now here the main concern is that the problem comes because of the potential difference. Just recall, so this is the one of the concept we learned, the concept under the concept of the potential difference. So what happens if the potential difference is, let's take, greater than the 34,000 volt? It's the order of the 34 times 10 power 3 volt. Now if this is the potential difference, now this potential difference causes A discharge of means this potential difference will affect this surrounding environment, and that surrounding environment will be having charges. So that's the reason. So this tube light, even though it is not connected to the wires, so it is starts to glow. And the same thing happens, this is the same thing happens if you apply more voltage between the two capacitors. Suppose if I take this is the capacitance plate, and this capacitance plate I applied a greater voltage. So let this voltage of, let it be take of 3 times 10 power 4 volt. Now if it is the 3 times 10 power 4 voltage, now here also it accumulates greater charge. One is the positive and one is the negative charge. And we know that the electric field is also exist between them. So let it be the direction of the electric field. Now if this is the potential difference what you applied, now the corresponding electric field will develop between the two capacitance plates is an amount of 3 times 10 power 6 volt per meter. So this is the amount of the electric field which will develop between the two capacitance plates. Now this is a huge amount, and this much amount cannot hold by the medium which is present between the capacitance plate. Now between the capacitance plate nothing is there, it means air is a medium. If this is the potential difference what we applied between the two capacitance plate, and the electric field present between them is 3 times 10 power 6 volt per meter. It means if you can take 1 meter distance, so 3 times 10 power 6 volt will be the potential difference. That is a huge amount, and that much amount cannot hold by the air medium. So by the times what happens, the air starts to charge, and if it cannot hold, by the times the charge itself they will start to leak. Suppose if we can show that the electrons from this plate, from the positive plate, so they won't take this path, and the charges electrons will take this path from this side to this side. So they will start to neutralize this positive plate. So that is the one of the problem will come if you apply more potential difference. So to reduce that effect, or in another manner if you can think, by using this formula, C is equal to Q upon V. So to store more amount of the charge with a small potential difference, the capacitance of a capacitor should increase. Not like that if you are applying the more potential difference, so we can think the capacitance also stores more amount of the charge. That is not the case. Each capacitor having a certain limit. So that capacitor more than that limit, it cannot store the charge. If you want to store more amount of the charge, one only thing we need to do, that we need to increase the capacitance of a capacitor. So there are certain methods to increase the capacitance of a capacitor. So that's the main reason why the capacitors comes bit why the capacitor comes in different sizes. So this is the main reason why the capacitance comes of greater to smaller sizes. This is all because of they can having certain limit, they can able to store certain amount of the charge only. So that's we will discuss in the next concept.